Hello everyone. So today we will learn a new new feature in C# 14, which is user-defined compound assignment operators. So let's go to the code to check this together. Okay, so I already created a console application. So first of all, C# keeps giving developers a little more flexibility with every release. With .NET 10, C# 14 introduces a feature that looks small at first glance but makes a real difference. User-defined compound assignment operators, meaning you can now decide exactly how operators behave in your own types. But why would you ever need that? And this question, and the answer for this question, we will see it together now. So first of all, I will create a class and I will rename it to energy. Okay. Then I will replace the class type with struct, and I will create here an integer value like this, and I will make it like this. Then I will create the operator function, or the operator what I will create now. This is actually using in C# 13 and earlier. It will not used in C# 14. This is not our feature. We will check our feature later. So I will create static energy operator, the addition operator. Okay, so I will put here the energy. Let's make it E and integer amount. Yeah, okay, so we will return it like this, or we will make it like this. It's better. We make it like this. It will be better. Okay, it will be cleaner from the previous one. Okay, so this one for the addition process, we can create for minus, for subtraction, and for the multiplication. Okay, for multiplication and subtraction and addition. So but here we have to create here minus also. Okay, so this is now okay. So this code, it will work in C# 13 and earlier. Okay, and this one actually, if you see here, we will return new instant each time. Each operator, or each calling this, we should create a new instance from the energy struct with a new value. Okay, so in C# 14 using Microsoft, they solve that, or they optimize that using user-defined compound assignment operators. So this one, let's say it. This one, it will be optional now in C# 14, the classic one, and this plus will return new instance. Okay, so the new feature in C# 14, it will be like this. So here we will have public void operator. It's similar of the first one, but here the return type is a void, not like a struct, a class, a void. So also it's like this. It will be like this. Okay, plus equal like this, and exactly we will make it for the subtraction and multiplication. Take care, we have to put it, yes, like this. Okay, so these codes, it will work only in C# 14, and this is the feature named user-defined compound assignment operators. So here, let's say in the here, if we put the language 13, this will not work. This will throw an exception now. Okay, why? because this is not available in C# 13. It will be available only in C# 14 and the new versions of C#. Okay, so if I put here, this will work. Okay, and so in this case, in C# 14, when I put this one, this will be the optional one, and this will be this will be the first priority. Then this will be the fallback one, the optional one. Okay, so now we will go to the program class to call this and understand it. Okay, so what we will need here, E1, I will create E1 energy and I will make it 0. Okay, so what I will do now, I will compare the first approach with the second approach. So I will compare this one with this one with, I will look with only for addition process. So to check which one is the better. Actually, just imagine that actually this one, if we understand it well, this one, it will be updated the value only without creating a new instance. In this case, it will be updated in a place. Okay, so it will be updated the value only. Okay, so it will keep the same instance. But here, the first approach for C# 13 and earlier versions of C#, it will create in each step new instance. So here, let's say this is in C# 14, compound assignment operators modify in a place. Okay, so this will keep the same instance, but it will change the value each time. So here we will make a difference. We will make a code to compare each separate and to know which one is the better. And just imagine that the first approach, it will negatively affect the performance, because in each step we will create new instance. So here I will add var SW stopwatch start new, and then I will add integer equals 0, then here I will make it 10 millions. Okay, so this will be like this exactly. Okay, or here I needed to make it like this. This is the first approach. Okay, this is the first approach. Okay, so the compiler, he will understand like this way. Okay, then I will stop and I will check the time for the first approach. Then what I will do, I will create another one, the same here, the value also 0, and then I will make the SW to restart it again. Also I will create a new, but in this case I will do like this. Yeah, like this. Okay, so this one, it will be the second approach to work in C# 14. Actually, both of them, both way, it will work in the C# 14, but in C# 13. Okay, so here, this way it will work in C# 13 as well. But it will not take this value. It will go to the first approach, which is this one. It will create new instance in each time. Okay, but the compiler, he will return it to this one. To this style. Okay, so what we will do now, we will just write console. Here we will put here, and this will be like the all. So if we run the project together, so if you see here, this is 40 milliseconds and this is 67. So this is much better from the first approach. The second approach, it's much better from the first approach. So if we run it again, we will have a different value. Look here, this is always, we will get the second approach. It will be better always from the first approach. And let's say for me, if I Okay, so this way, what I will do now, I will just comment this code. This will not work now. Yeah, why this is not work? Because we already comment this code, and this code, it's the first approach, and this code will work only in this case, in this style. Okay, in 1+1. So here will work fine. Why? Because in C#13, in C#14, it will use the second approach when I want to write it in this style. It will use the second approach. Okay, so it will work in this case. But if I comment this as well, so this is now will throw an exception. Okay, but we just need to understand something here also. So now everything will be fine. Yeah. So if I go to the 13 and make it 13, so now we will have we will throw exception here because this is only used in C#14. But if we here go to the program, look here, both of them is working fine now. Both of them are working fine. But the thing is now, this one, it will not take this. So for example, if I remove this or I comment this one, okay. So this one and this one, it will be equal. Okay. So this one, the compiler, what he will do, he will return it to this style, and then he will give the result. My final thoughts: the introduction of user-defined compound assignment apparatus in C#14 might be like a small step, but it's a meaningful one. It gives developers more control over how their types behave, making the code not only faster, but also more expressive. Used in the right places like game loops, physics engines, and math-heavy libraries, it can help you squeeze extra performance out of your code without sacrificing readability. In the next session, we will talk about a new feature in C#14 called New Preprocessor Directives for File-Based Apps. Salam.